I want to show you guys something that's a little bit different than what I drew up in my notes. I did it in my notes specifically to get you guys thinking about something, but I wanted to show it differently here. So these are phase changes, and it doesn't matter the substance, okay? So I want you to focus on delta H. I want you to focus on the black here for a second, okay? So this is going solid, so heating a solid, solid to liquid phase change, liquid, heating the liquid, liquid to gas, boiling, and then heating the gas. You're just superheating the gas, spacing the particles out from each other, okay? So you're adding heat at this point. This substance, whatever it is getting heat added to it from the surroundings. That is the definition of endothermic. So this is going to be a positive delta H for this process, which I know is always a little awkward to think about at first. But this is positive delta H. So heat is getting added to this substance, and you can see it from the graph. It's pretty clear. Okay. So let's think about what's going on with entropy the exact same way. Now in your notes, I made the y-axis order. So it was actually going in the opposite way, which may have thrown some of you for a loop. So I wanted to draw it this way with my y-axis being disorder. Let's think about it for a second. So when you heat a solid, you're not really creating a ton of disorder, but you are making those particles vibrate a little bit more. I mean, if you take something almost down to absolute zero, there's almost no molecular motion. And as you heat it up, there's a little bit more vibrational motion, there's a little bit more. You are dispersing energy a little bit more in its own way. You get to a phase change. Oh, yeah, you're really going to disperse some energy here because you're going to make those particles go from a solid to the part where it's a liquid, and they're really going to move away from each other. Then you go to a liquid, and those particles are going to be, again, until you really go through a phase change, those particles can't really get away from each other any further. But energy is going to be dispersed. Those particles are moving faster. They're moving away from each other even more. You go from a liquid to a gas, again, all those particles have to go from the liquid state to the gas state, so they can't really get any further away from each other until they've all transitioned and they've finally gotten away. You could almost draw it like this. Which is a little bit weird to think about because the entropy really increases at the phase change for the particles because that's when they get away from each other. And then once you superheat the gas, I mean, how much further away from each other can they get? But the point should be made here that when you're adding heat to a substance, it's an endothermic process, but you're also increasing the energy dispersion at the same time. So they're moving in tandem. So energy increases to the substance, it's endothermic, it's taking in the heat from the surroundings, disorder is increasing. So entropy increases, which means disorder increases, which means order has gone down, which is why I drew it the way I did in the notes, which is one way to think about it is the energy of the substance goes up, the order contained in the substance goes down. So then if you think about how the opposite would look, what would happen then if you cool a substance? Well, they're going to do the same thing. Here's your gas, gas to liquid, liquid, liquid to solid, solid. Well, they're going to move the same way, and let's pay attention to the signs and what it means. Boop, boop, gas, gas to liquid, liquid, liquid to solid, solid. So what does this mean for delta H? So the substance is cooling. So if the substance is cooling, it's releasing heat to the surroundings. This makes delta H negative for the substance. We've done this before. Now let's think about what's going on with the entropy here. Oh, you're going from a gas to a liquid. You're bringing those particles together. They're less dispersed. You're cooling the liquid. Those particles are still going to be a little bit closer together still. Liquid to solid, you're freezing it. And now you've got a solid where you're decreasing the motion. Oh. So your entropy decreases. That means delta S is negative. Disorder decreases, order increases. And I drew order in your notes. Keep them straight. Entropy is a measure of disorder. So if disorder increases, it's positive. If disorder decreases, it's negative. Disorder is decreasing, order is increasing. There's a lot of flip-flopping here you're going to have to keep straight. You're going to have to make sure you keep your signs straight. Okay?